In this project, we proposed to attach a tactile sensor to a biped robot's foot so that it could use the perceived center of the pressure to aid its balancing, as well as other functionalities that come with having a vision-based tactile sensor. We incorporated a gel-side sensor on the foot of a bipedal robot to achieve the desired functionalities. The raw images from the sensor were processed to perform different tasks. We were also able to detect the location and orientation when an edge of a cube was pressed. Using the gel-side technology, the sensor was able to perceive the depth of the pressed object, a few pebbles in this case. Incorporating 14:9 markers allowed us to detect shear forces, which could be applied to detect slippage for later applications. We estimated the center of pressure on the sensor by detecting blobs present in the collected images. The average value from the coordinates of detective contours were used to create the moving line displayed over the sensor image. The practicality of the estimated center of pressure was tested by placing the robot on a motorized rotating platform. In the top row, the robot's motors are powered to stay stiff, but no feedback was given to turn the motors. In the bottom row, the robot's ankles were turned with a value given from a PID controller to minimize the error between the geometric center of the sensor and the estimated center of pressure. The experiments were done over varying angles of the rotating platform, both inclining and declining. The summary points out how the system performed under different conditions. The red background indicates incidents where either the robot failed to recover balance or had to be stopped by the harness to prevent fall. In the following experiment, we tested our sensor's ability to detect the terrain while the robot was walking. The field was covered with a white fabric, and thus the type of terrain was not visible. The detection model was trained with ResNet50 as the backbone. The image below the robot's video reveals what's under the fabric for reference. The text on the top of the sensor image denotes the terrain with highest confidence and its confidence in percentage.